There are a number of learning theories that really drive immersive learning, and here are what I consider to be the top 5. Now, from a situated cognition perspective, a learner's cognitive functions within a learning activity and the context in which they take place are interdependent. And so what that means with VR experiences is that it's really a powerful method of modeling systems by situating the learner within a real life setting. So this modality can really enhance that situated cognition. Now, Dewey's experiential learning theory also claims that learners learn by doing and by constructing knowledge through active engagement in the learning environment. Now, I would argue that virtual reality provides an optimal environment for experiential learning. It enables learners to be really active participants in their learning process through interacting with the virtual world around them, transforming this experience into cognitive understanding. Now, constructivists believe that learners also must interpret their experience and make meaning of them for learning to occur. Now, learning through trial and error is the basis for many virtual reality learning experiences. In VR, learners can really explore and test out their solutions. They can receive feedback and they can interpret this experience and really internalize the meaning of it by uncovering the interrelationships between concepts and the cause and effect relationships that they actually experience firsthand. There's also flow theories, coined by Mihai Csikszentmihalyi, which is a state in which you're so completely absorbed or engaged in an activity that all else is ignored. And it's really achieved when you can strike a sweet balance in your design between challenge level and skill level. And when we design for virtual reality, one of our goals is to get learners to this flow state, this optimal state of mind, as quickly as possible. And you can find that this same sort of balance between challenge level and skill level required to both reach and maintain flow is similar to that of Lev Vygotsky's zone of proximal development. And then there's cognitive load theory. So it's critical for us to really consider learners' information processing limitations and design to sort of limit the amount of extraneous cognitive load imparted on the learner within our virtual reality training. Now, we can apply what we know about learning science to really help us make decisions for our designs in virtual reality. So, for instance, if we were trying to promote situated learning theory, really to maintain immersion and situated cognition, we may ensure that our spatial environment is authentic and realistic, and we might also opt for diegetic interfaces. For experiential learning theory, we might design for guided discovery, replayability, and implement space practice. And we can also encourage knowledge and skill acquisition by designing for the right level of challenge, right? Implementing just-in-time support or formative feedback mechanisms. And then facilitate reaching a flow state through very clear goals, a sense of control for the learner, appropriate challenge level, and immediate feedback, which are all precursors to reaching and maintaining flow. And to limit the amount of extraneous cognitive load we might impart on a learner, we might limit the amount of text on the screen or ensure that our controller manipulations for our virtual reality training mirrors real life actions.